Oh, one, two, three. Hello, everybody. Well, welcome back. Welcome back to the channel. Um, I've been very busy traveling for the last 6 weeks or something like that. I was in Mexico. It was really awesome. Actually, I got into like a very good productivity groove where, inspired by the awesome productivity of Ink Heaven, this rationalist incubator of blogs, I was inspired to like, okay, can I write a blog post every day? And so at least for a little while, on a little streak, while I had a kind of a routine in Mexico, but interrupted with all kinds of fascinating meeting and events. I did manage to write like one post a day for a while, and in that process, a lot of my thinking got clarified on a number of ways. But the most important aspect of it, the most rewarding, really, is that a bunch of the backlog of ideas that I hadn't quite put in writing yet or in videos, you can actually now read in Substack. Um, I will continue to write, quality computing posts, QRI posts, making these videos, and also I'm gonna be sharing more videos in general. I think of like more casual conversations. For example, um, I had a couple conversations with several philosophers over the last couple of weeks, some of which got recorded, and I'm going to be uploading them. Don't expect the answer to everything in any one of these recordings. Really, it's just kind of building the body of work, demonstrating all of these fascinating conversations and how the threads get woven together into insights for how to make sense of consciousness. Well, today actually I want to talk about like kind of two interrelated topics that build towards what I believe is hopefully a genuinely compelling solution to the meta problem of consciousness. So let me go in parts. First of all, what is the meta problem of consciousness? This is not just like, hey, how can like form and structure give rise to subjectivity, like quote unquote the hard problem of consciousness, but why is it that we find consciousness mysterious and so hard to explain, and why we stumble upon it, right? Like stumble with it. Like we have so many beautiful theories of, for example, how particles behave, and how plasma behaves, and chemistry and biology, but even AI, right? Like we know how to process an image and extract features and say like, hey, there's a face in here, but somehow the fact that we have qualia, and bound experiences feels genuinely mysterious. In a way that it interacts with your world model, right? Like it's not that consciousness feels mysterious, to core, to just as it is for the most part. It really is because our model of the world fails to account for it in some way, right? And there's some people who might say, hey, like like science and religion, they live in different spaces, different magisteria, as Stephen Gould would say. Um, but there's a very simple reason why this is not the case, and why everything does come down to the same empirical basis. All theories are ultimately evaluated by the same criteria, and that is, are they good at predicting experiences? What experiences you're going to have, right? When I say, hey, when I die, I'm going to go to such and such heaven. Well, that's a claim. I'm making a prediction about my future experiences, right? And that's, even though the epistemological handles that such a claim may have are different, it is still of the same fundamental kind as saying, hey, if I turn on the stove and I put my my hand on the red hot stove, I'm gonna feel a lot of like pain qualia in my hand, right? Like this is an empirical claim that relates to experience. In fact, the very word empirical, etymologically, ties back to relating to experience, right? So the unity of experience is empirical, the features of experience are empirical, and the way in which experiences are related to each other are all empirical matters. So consciousness, I think it's very puzzling because we with our current frameworks, we can't kind of predict the fact that a system like us would be conscious in this sense of having like a bound qualia field, world simulation. So then the question becomes like, well, what kind of systems could do this? And also, among the systems that could do this, which ones would actually be confused about their own nature? And which ones would actually have, some chance of figuring out what they are more fundamentally. So what I'm going to talk about today is really just these two kind of like legs of what I hope will eventually become like a complete explanation for the meta problem of consciousness. And that is A, what kind of like systems, dynamical systems, or maybe in the more abstract sense, computational systems in the very general sense of a computational system, could conceivably give rise to moments of experience. And then the other topic is within those systems, which ones would actually have some conception about consciousness and maybe have the hope of actually achieving like self-awareness, metacognition, and ultimately, decipher the very nature of consciousness itself, right? So on the first part, here's where in recent blog posts, I think I introduced this in, first of all, in an article in Substack called The Reality of Wholes. And in here, I essentially break down kind of like 3 tiers of computational systems very broadly, and then argue that just based on the fact of experience alone, we must be in a tier 3 universe or tier 3 kind of existence or ontology. And then we can know these for a fact, however tempting it may be to believe otherwise. So tier number 1, this is, let's say, like the standard, Conway's Game of Life cellular automaton, where you have kind of like one universal time. All of the states in the grid have a certain time assigned to it and a certain state assigned to that time. And then the way you evolve the system is you look at every one of the buckets, where in this case it could be 1 or 0 as part of the content of the bucket. Then you look at its neighbors, and based on a series of rules, you update, the state of the central bucket as a function of its neighbors. With the classical, Conway Game of Life, kind of like straddling the balance between, well, if there's too many on buckets, then you can't survive, and if there's too few, then also you can't survive. So like the patterns that survive are those that are kind of in the sweet spot of how many of the buckets around them are active. And that produces all kinds of incredible, emergent patterns. But here's the thing, strictly speaking, anything that arises in a tier 1 system will, by its very construction, always be nothing more and nothing less than the sum of its parts. Like you can apply something like integrated information theory to analyzing patterns that emerge in that world. However, any kind of like notion of integrated information that emerges there is really a convenient or economical coarse graining of the system that allows you to compress what is happening in a way that is convenient for your own tracking of what is going on, right? Like the moment you see a vast empty space and a tiny glider, and you have kind of in your repertoire of patterns that you have learned of this system, the glider, then you can infer, well, it will continue to be a vast empty space and just one glider moving, right? So it allows you to compress what is happening, and really kind of like predict your own experiences more effectively and efficiently. However, strictly speaking, at no point really fundamentally there's any kind of integrated information in any strong sense, like only in the coarse graining sense, or in the sense of, hey, for patterns of this size from this perspective, this way of looking at them makes them seem like, the sum is greater, or rather the whole is greater than the sum of the parts. However, by construction, the largest kind of like unit of information that exists in this system is either, you could say, well, the system as a whole, the entire grid all at once, or, any given bucket and its neighborhood at most, right? Like there's no any update anywhere in the system that is using any more information than that, right? So in that sense, there's no way you can kind of like draw a boundary around a region of Conway's Game of Life and say, hey, this is a bound experience, because you don't have the right necessary criteria for that. You don't have like any boundary making mechanism. And on top of that, the boundaries are not in and of themselves causally significant in any way, right? Like evolution would have like no reason to recruit them for information processing. which is not to say that there isn't fascinating evolution happening in this type of system. And as we will see in a second, there might even be observers in that system for a certain notion of an observer. The second type of system is something that in the literature you can find as, process physics. Here's the idea is like, well, you get rid of the universal clock, right? Like really all of the interactions are completely local. Physicists are actually very motivated to do this so that they can move beyond, Newtonian mechanics and the whole Wolfram project of like, hey, like, can we find general relativity or Lorentz invariance in like certain types of cellular automatons? Well, you're not going to do that in Conway's Game of Life, right? Because of the universal time and the updates happening in parallel synchronously. In reality, there's no universal plane of simultaneity. It's entirely relative, entirely based on like local conditions. But interesting things can happen when you have like sophisticated rules that act locally, where you can have kind of like not a variable window, but rather a window that grows with the number of connections that each of the buckets has. And maybe that is something variable. So one of the things that you have is that, well, regions of this network that are more interconnected have like more things happening in them. In other words, if kind of like each of the nodes in some sense has like an internal clock, and based on that internal clock, it makes updates, and the number of updates that it makes, switches its internal clock, you can very much expect that, well, where the network is very dense, a lot of time is happening, so to speak, right? So from that type of reasoning, you may be able to reconstruct, time dilation effects and the strange relativistic effects that happens when you have like very contrasting speeds. The problem here, though, is that, the unit continues to be fixed. You have like these fixed buckets, and there's like all the information. So like there's no moment where you have like an aggregation of information where the whole becomes more than the sum of the parts. Even here, strictly speaking, at every one step, what happens next is still just exactly, the sum of the parts plus the rule set. And because that is, fixed and is not variable, you don't have the capacity for essentially having like a larger holistic system that acts as a unit. It's still just individual local rules. There is one important caveat here, which is that you can kind of like modify these systems a little bit and then turn them into system 3 without realizing it, in which case you do have like genuine holism. But usually here you will be able to find like, hey, in what way you're subtly not in a system 2 anymore. The system 3, to be very explicit, has actual holistic rules. So here, I want you to think of it instead as like, well, it is a kind of computer, but it's a general type of computer. And a general type of computer allows arbitrary, physically integrated kind of unitary states as inputs, as internal steps of processing, where like these states are combined, they're fused, they're fissioned, they're copied, they're mutated, and then as the output, you also allow kind of these integrated physical states. So, I mean, in some sense, maybe there is a general quantum computer that can be built that can actually do everything that this universe can do. David Deutsch has actually like talked about it, even though for some reason his work is actually used to justify like the more conventional computationalist perspective. But in reality, he's talking about how you could get like general physical processes to be emulated in a general quantum computer. And that actually, I think, like has legs, that can actually, that tracks, because you do have kind of these integrated physical states that you're using as your units of processing, right? Like your very ontology. And so, a classical computer will never deliver as an output a quantum coherent system, or a soap bubble for that matter, or or like a lead atom, right? Like or a particular molecule, right? Like by its very design, all it's really going to be doing is like shuffling around ones and zeros in, at most at tier 2, but typically they're constructed so that they're actually functionally tier 1. Here's an important clarification though, which is that the universe itself may be like tier 3, but it may give rise to like tier 1 lookalikes, even though, fundamentally there's still tier 3 from the point of view of whatever is being processed at the algorithmic level. There's still generally tier 1, and you can't make that bridge without actually tapping into the physics that implements the system. In a tier 3 system, you have potentially, both local rules that are updating the states of the nodes in this case, but then you also have a kind of like meta rule that says, hey, when certain conditions are met, and in the what I call the page rank monadology concept that I worked on in the posts, this is, the trigger here is the detection of like what we might call a strongly connected component, a property of directed graphs where a certain region of the graph is such that from any point you can arrive to any other point in that graph, but you can't, escape to the broader graph. And so in a way, this would be kind of the regions where information or the flow of being, perhaps more directly, gets trapped. Now, the meta rule says that, okay, whenever you find one of these boundaries, then you apply a holistic update. And, the straightforward example here is PageRank. And, like PageRank was used back in the day by Google to kind of estimate, hey, if you click randomly from one link to another in the entire internet, what is the probability that you will find yourself, at a given website? So think of it kind of like similarly to that, is like you can absolutely compute this in a classical digital computer. However, you will need to serialize it, and you will need to kind of like do local updates, or, in the case of some of these algorithms, you do like these matrix multiplications until you achieve like convergence, or you find like there's like a bunch of tricks to kind of like find it a little bit faster. But still, though, fundamentally how you're implementing it, you still need to individually read, like all of the values of all of the nodes and how they're connected to each other, and then make local updates one at a time and have like a memory cache where all these partial operations are kept track of. What I'm saying here is that a system 3 or a tier 3 system has this kind of like PageRank step as just one step. The moment you close the boundary, then as a whole, almost kind of like instantly from the point of view of an external observer, the weights of the nodes have updated. And now based on these updated nodes, you reconnect the graph and you change its connectivity, its topology. This way, you generally have kind of this like two-step structure where you have like local rules, then a holistic trigger gets activated, which triggers a holistic update. And then that holistic update feeds back into what the local rules will be applied to. I hope this makes sense. I mean, this is really just kind of a conceptual category of like a type of system, right? Like, I don't want you to like focus too much on the PageRank, not even too much on the fact that we're using a graph here, right? Like, really is like structural and conceptual. What I'm trying to point at is there is some mechanism that enables a component of reality, as it were, to behave as a unit that is kind of like this variable individuation, right? Like what belongs inside the boundary and outside the boundary depends on the local conditions. But then once the boundary is established, you have behavior that it would be like too fast from the point of view of individual updates, or there would be nowhere to put the computation from that point of view. And that it genuinely, may actually accomplish something interesting or useful or recruitable from the point of view of like patterns that are like evolving in such a universe. Now, I would argue that, just the fact that moments of experience contain many pieces of information at once, and I think this is, this is a fact. You can ask, how do we know for a fact, and question kind of like the validity of introspection, and that's a very rich topic. We could talk about it for hours. For the time being, I'm just gonna say, hey, this is a fact. It's like an explanation. That's something that you have to explain, something that you start with, and it's as empirical and as obvious as it gets. Even the etymology of like what it's obvious means in front of the road. It's front of where you're going, and the unity of experience is obvious in that sense. Like, it is true that you don't experience everything simultaneously, quote unquote, But the information that you do experience, involves contrasts and involves like reshiftings of attention, all of which, even just a basic contrast, like the contrast of two colors in the wall, that already contains multiple qualia simultaneously. Or maybe you could say it contains a new qualia, which is the gestalt qualia of the contrast itself, right? But like that's not contained in just finding the individual kind of like pixels of experience and kind of like adding them up. Is like there's like generally some co-witnessing operation that is closing, hey, what is the qualia that it is being co-witnessed? So based on that alone, we can infer that the universe must be a tier 3 type system or greater, or something even more sophisticated. Because the moments of experience have this holistic property. For some reason, they're being recruited by natural selection for something useful, and they're fundamentally unitary. I mean, like, not unitary in the sense of physical synchrony, not unitary in the sense of even just basic resonance, but unitary in a much deeper sense, as kind of like being part of the same perspective, and that perspective having holistic effects. Now, here's the thing, though. Even here, you can infer based on the facts of the matter, the facts of experience, that, hey, the universe must be this type of thing. It doesn't tell you yet exactly what are the rules, and what are the updates, and what kind of like holistic triggering mechanism is in place. You need to do a lot of work to get there, right? Like, but I do think that, if we were like really, really smart, we would be able to, at least in principle, derive, mathematical properties of the quantum mechanics of the universe just based on phenomenology. Maybe not on like normal phenomenology of everyday life, but if we could have like a research program that investigates the jhanas and DMT and 5-MeO DMT and, states of dissociation and so on, based on how attention and awareness combine to create all kinds of, strange symmetrical high valence configurations, or whatever the case may be. I think we might be able to reverse engineer, hey, like, what are some of the key constraints on the type of tier 3 system that this universe runs on. However, I do think this is like very, very hard, very difficult. But if we were like, a society of phenomenology geniuses with mathematical aesthetics, I think there's a chance we might have arrived at quantum mechanics from phenomenology, right? Like from this type of reasoning first and foremost, and then eventually confirming it in actual physics, which would be so funny, like the papers in that parallel parallel reality where people are like, well, we have known for a long time, that quantum mechanics are required to explain consciousness, but the idea that quantum mechanics is happening at the level of atoms and that it has something to do with interference patterns you see, in an optical experiment in a laboratory, that's completely far-fetched. That is crank territory. But now, we find ourselves in kind of like the mirror world of that timeline. But yeah, I mean, I think we can infer for a fact we exist at least in a tier 3 universe. Now, you still have to explain, like, hey, how is this related to an epistemic agent or kind of like an observer? Observer, let's say, building on the work of like Senchal, who I had a conversation with, and you can see a write-up about that conversation, who's working on, observer theory within kind of like a Wolfram ecosystem. Like in that world, you define an observer in terms of properties such as, the boundaries of it, its capacity for preservation, and then its capacity for taking into account its external input and minimizing its free energy by trying to essentially predict, what's going to happen next in its environment, so that it can use that to evaluate what it is, and also create like boundaries around its scope of action. What is it that it can do? How can it interact with the world? So you can really kind of like formally and from a computational perspective define observers in that way. But here's the thing, with that kind of conception of observers, you very likely will be able to find observers if you apply, that a mathematical formalism of that conception to something like Conway's game of life. You may even say something like, well, at a very basic level, something like, the glider on the Conway's game of life is itself a certain kind of observer with a certain kind of boundary and persistence and ability to predict its environment, at least implicitly. And yeah, when it comes to much more sophisticated machinery, if you implement a complex neural network sitting on top of a multi-layered, game of life system, you very likely will be able to say like, well, hey, this looks like an observer, at least like statistically speaking, and this looks like an observer, and this looks like an observer. And especially if there's evolution, where having these boundaries and persistence and being able to predict the environment are all evolutionarily adaptive, you will be able to find these kind of epistemic observers there. However, because there's still no holistic update rule, there's no mechanism that is making it act as a unit beyond just the local rules, like where it really strictly still is nothing but the sum of its parts. For that reason, it's not going to be a phenomenal observer. It's not going to be an experience. It's not going to be there's not going to be like any co-witnessing relationship between the information content of a moment of experience in that world. But here's kind of the interesting twist here. I would argue that, well, let's define, how to compute an observer quotient, as it were, and then apply it to systems that evolve in, let's say, a tier 1 system, then, patterns that evolve in a tier 2, patterns that evolve in a tier 3. And my claim is that the observer quotient will kind of like unusually spike, at least under certain evolutionary conditions in, tier 2 and especially tier 3 systems. In other words, precisely because this reality does have this holistic update rule, it is something that epistemic observers would actually be incentivized to use as part of their, information processing pipeline, as part of the replication pipeline. Of course, these are nested processes. It's similar to like integrated information theory, right? Like IIT in its, mathematical formulation will tell you that, hey, some Conway game of life like systems have like, these like sparks of integrated information here and there. But if you were to apply the same math to something that actually has much more potential for kind of like fundamental radical integration and this holistic behavior, IIT will essentially be telling you like, well, yes, the glider kind of has a certain IIT integrated, quotient, but oh my gosh, the observers that emerge in tier 3 systems have huge amounts of integrated information, like spikes of integrated information. So in a sense of these metrics, kind of like an observer metric or an integrated information metric, I don't necessarily expect that they will return 0 in Conway's game of life, but I do expect them to return very large values suddenly when you do start using phenomenal binding for information processing. I hope that makes sense. I mean, it is like a tricky conceptual, it's kind of like putting it on its head, right? Like I'm not saying integrated information is what consciousness is. It's like it is, two sides of the same coin or something like that. Really, I'm saying integrated information is a mathematical tool that relates to coarse graining systems, but which you still expect to show a spike when you have genuine kind of this ontological, monadological integration. So, that's like kind of like the first. Like the second part is, well, how could like observers look like, even if you exist tier 3 system, you might still have kind of like different instantiations of those worlds, right? So I want to kind of like walk you through like 4 options here. The option 1 really is kind of just Conway's game of life again, in a sense. Is like, let's say you create a simulation in a digital computer. Well, here by its very construction, you will not have these, holistic behavior that matters for the computation. And so like, okay, like the monads, maybe there is like some notion of a monad in the computer in that like different circuits create like, bounded topologies here and there, but that boundedness doesn't feed back into the operations of the algorithm, right? Like the algorithm is really being implemented at the level of interaction between monads, as opposed to like anything happening within a monad being computationally significant. I hope that makes sense. I mean, in fact, like the way you build these systems is by trying to narrow down and reduce as much as possible the influence of the processing inside monads, and trying to restrict everything to like lawful between monad interactions. Well, there's another like possibility though. Like you could imagine kind of like a world where you have set up this gigantic grid. Within each grid, you do have, let's say, like 100 atoms, or like 100 molecules that can interact and enter into a quantum coherent state and do all kinds of holistic behavior. But then the way in which this holistic behavior scales is limited by the fact that each of the buckets can only interact lawfully with its adjacent buckets. And so maybe you kind of like remove the boundaries between adjacent buckets in a periodic fashion. And so periodically, a bucket can like double in size, but then it's going to be halved again, right? So here, even though you have kind of this like monadological integration of information, you still wouldn't expect, a phenomenal observer, as it were, right? Like, because the observers, computational speaking, that exist would arise at the level of kind of the interactions between these monads, and at no point you would have like a monad that spans many of these buckets simultaneously and has a top-down causal effect. Now, you could transform that system into something like that if, for example, what you do is how many buckets you allow to be part of the same integrated unified monad. If that depends on the individual monad configurations, then in a lawful way you may trigger these holistic states that then influence the behavior of the system as a whole. And maybe the brain is like that, right? Like maybe the brain kind of has that feature that like, well, each of the neurons is kind of doing its own thing. Even the microtubule structure of each neuron itself is a very complex neural network of a certain sort. But then there's like a mechanism such that, hey, like when a certain neuron can be the fact that it can be really good at predicting or minimizing energy or doing something metabolically efficient or useful, then it briefly gets allowed to be part of the broader monad. And the broader monad incorporates the contents of many neurons simultaneously. But conceptually, that already puts us into a completely different territory, what I would call the monad observer system. And that would be kind of like the brain. So like at the very center, arguably, maybe spanning the thalamus in its segmentation, you have kind of like an optical image that is topologically closed, and then you have a lot of these like images that are trying to merge with the central one. There's this kind of crazy long tail of increasingly smaller and smaller like micro experiences that really contain just kind of like the solution to various local constraint satisfaction problems that are trying to fit together into this unified kind of coalition of perspectives that form the central monad. And constantly, the central monad is maybe like flickering on and off, kind of like this coherence moment that maybe happens like hundreds of times per second. But all of a sudden we're talking about a very, very different type of system than either a digital computer or like the other one that I was talking about, kind of this grid of, fixed buckets of, maximum, where the maximal monad is just two squares adjacent to each other interacting. And then finally, the other one that we have to talk about, and I think like empirically we can rule out, is the mega monad. I mean, this idea that, well, the entire universe is just one gigantic experience. I could see arguing for that if we kind of redefine our terms or if we really radically kind of shift our ontology. But if you do give credence to, hey, phenomenal boundaries are doing some non-trivial information processing, or they're accelerating something, or they function as a kind of like causal multiplier, or even like a timeline timeline selection mechanism, or like it boosts probabilities for some outcomes or something of the sort. Without that, you're not going to have experiences as we understand them, right? So I don't think it makes all that much sense to say that all of existence is just one gigantic experience. Rather, you could say it's a network of experiences of variable size that has an internal and collective topological structure. Maybe you could say the universe is a gigantic mind, but it's not a gigantic experience. Although maybe it is a gigantic experience every now and then, or like maybe like between 1 second and another, maybe the entire universe becomes unified and then it fragments again. That's another possibility. But you still have to explain the fragmentation that we do know exists and is real, which is like, okay, this moment. So what I want to say is that, based on all of this reasoning, you can arrive at a picture where, we are something like this. Like, actually, kind of self-awareness is always a little bit illusory, right? Like, because you never kind of like become aware of yourself as a monad. What you can become aware of is how monads interacted in order to give rise to your current experience. I mean, in some sense, the output of your current experience might be this like self-reflective step. So it's not like you can become aware of it. However, you can become aware of the echoes of the previous self-reflective step. And so really to become self-aware, as it were, like to understand the structure of reality and how it connects all the monads together and so on, is something that can only happen in very specific circumstances where you're in a tier 3 universe that has gone through well, very big, amazing, terrifying, incredible process of evolution, where the sizes of these monads learn, so to speak, or evolve to be such that there is a central one that functions as a kind of mini world simulation of the environment, but that eventually, in order to predict itself and its own mechanics, it needs to pay attention to how monads interact with each other. I mean, and that itself becomes part of the error signal that it's trying to minimize. And so very rarefied, advanced, enlightened state of consciousness, as it were, may involve kind of this like learning process where you're not only learning how to minimize prediction errors from your environment, you're also learning how to minimize your own prediction errors, or the prediction errors that arise from the interaction between the monads. And so when you pay attention back onto itself, as it were, metaphorically speaking, you're training a monadological system that can predict its own dynamics. Now, there's probably a lot of near enemies here and false starts, and there's many metaphysical views that maybe accomplish these quite well, but not entirely well, right? And I'm not aware of any theory of consciousness that can accurately, for example, anticipate and predict what happens on DMT. Like that seems to me like outside of current empirical science. Just in terms of like, the mathematical structures that emerge and the complexity and the holism that is involved in such experiences. And that is something that, I mean, it is kind of like running a quantum coherence experiment, right? Like in principle, you can solve Schrodinger's equation, but it might take, longer than the time of the universe for a very sophisticated system. Well, here is a very sophisticated system learning to model itself, or learning to model its own boundaries. The last kind of like insight here that I will leave you with is that there are kind of like tiers of knowledge as well, or like self-knowledge, right? Like, because what presents itself in experience is really whatever has been like optimized for the replication of the genetic vehicle that gave rise to it. And so by default, we come into this world as the central monad of our experience without not that much kind of like self-understanding, right? Like we don't even know for the most part like whether where our boundaries end and where they begin, whether we're a whole body, whether yourself ends at the point the hairs start to grow, or like do you also include the hairs. And there's a lot of kind of like models of what you are and what your boundaries are that are like decent enough at predicting future experiences that if you just run with them, like you're actually fine for the most part. Like you really only encounter in what way your self-concept is actually totally insane when you look, in the regions of the state space of consciousness that drastically contradict, your predictions. And yeah, I would say like high-end meditation, DMT, 5-MeO DMT type stuff really challenges all of these models, as well as like logical reasoning that is very grounded on first principles. So what I will argue is that actually like self-awareness in this like very deep sense of kind of like a monad becoming aware of its own properties is generally kind of like reality transforming, right? Because you're creating a new structure, and that is like, hey, you're creating how a quantum coherent system reacts to itself for the first time on a certain configuration, something the universe may not actually have encountered before, or like have the means to predict or anticipate. It needs to run the experiment. But once you identify one of these beautiful attractors that maybe really, really minimize a lot of the prediction errors internally. It's an attractor that might be like really solid, self-replicating and anti-fragile. But it might require a very, very thorough search process with a lot of near enemies. So hopefully this sparked some interesting ideas. I just figured I would share it while it's very fresh in my mind. So, I'll keep posting. There's a lot of plans for QRI this year. Actually, we're holding a low key QRI meetup at Dolores Park in the section E3. You can see the announcement on Twitter on Sunday, this Sunday, the 1st of February. I believe we'll be there from 2 to 5 p.m. Feel free to find me physically if you want to ask me anything. And we held a successful meetup in Mexico. We will continue to expand and really drive forward with some of the key objectives of this year. And yeah, I mean, I'm hoping to really get in the groove of regularly uploading, hopefully philosophically clarifying videos. Well, you tell me if it's philosophically clarifying or if I'm just tying you further into knots. So yeah, be in the lookout for what's happening in this space. There's a lot going on. Infinite bliss, everybody. Take care. Ciao. See you next time.